concerned that, you know, he's wearing a crash helmet. It's not really going to be that much protection if the car lands on his head. But basically they went through and they did this at this test. And I kind of thought, well, you know, how can we make this happen in the game world? So what I did, and I can switch back to the sort of workshop version of the game, was I decided to make that happen. I actually did this morning in the hotel room. So I've basically built this Top Gear test car, which is an actual class. And I really wanted to show a bit about how that Euler calculation works, because in the actual game model itself, there's so many different variables going on there. It's kind of a challenge to actually show that code on the screen. But this is a bit more basic. It's just a falling object that we're going to be simulating. So again, I'm starting off with my constants. We've got an actual friction coefficient. We've got the mass of the car. We've got the gravity, you know, 9.8 meters per second. We've got the up direction and the forward direction. We've got the position where the car is going to land. We've got the height in meters where we're going to drop the car from. And we've got the actual track sector in the game world where the car is going to hit the track. And that's basically used to calculate when the car hits the track, are we before or after that particular track sector. And that's going to decide if we've actually passed the Top Gear challenge or not. Variables, we've got position, velocity, and then sort of whether the challenge is complete. And what I'm doing really is basically, you know, when we create a new instance, we basically put the car at the full position plus the height. And again, these are vector 3 calculations that I'm using. So I'm figuring out where the car is going to be when it starts off. The velocity is going to be 0, and challenge complete is going to be false. So this happens when we start a lap. And then we've got the actual Euler physics method here, the update method. And again, this is kind of, you know, what I was talking about on the slides, where we're going to be getting the frame time. And the frame time is going to be in fractions of a second. So the first thing that we do is we calculate the aerodynamical drag force on the car. And remember, that's equal to the velocity squared multiplied by the drag coefficient. Now,